Okay guys, I'm feeling in a very festive mood today, so I've decided to extend the time for this enumerations assignment, this last one that we did. Just a couple of you have turned that assignment in, and obviously there was some confusion perhaps, and some lack of understanding in terms of exactly how we configure this and put this together. So what I've done is change this due date until Thursday the 11th at midnight, so I'll give you a couple more days to do this. If you've already turned it in, feel free to revise it and turn it in again. That's not a problem. So what I'd like to do is to show you exactly how to set this up. So here we go. Here is the first card program, the card.java file that you downloaded, that has this rank and suit fields as integers, then all of these public, final, static integer constants, diamonds, clubs, hearts, spades, representing the suits. Public simply means that they are accessible outside the program. Final means that we can't change them. They are essentially integer constants. Static means that they exist even when no instance of the card class exists. And integer, of course, is the type. Then we've got a similar situation for all of these ranks. The face value of the cards, ace all the way down through king, with their corresponding integer values here. Then we've got a public constructor here, so when we create a new card we pass it a rank and a suit. Again, these are just integer values, 1 through 4 here, 1 through 13 here. And then this isValid rank and isValid suit, these are just a couple of functions or methods that are down below that just validate that the rank and the suit are actually within the proper ranges. And then this assigns this parameter variable rank to this rank or the rank field for this card. Same thing for suit. Then we've got a couple of get methods here to get the suit, get the rank. Then here are the isValid rank and isValid suit methods, just validate that the ranks are within the proper ranges. Then we've got a couple of interesting rank to string and rank to suit method, or suit to string methods here, and all these do basically are take a look at the value of the suit that's passed and assign this string value, or actually just returns the string diamonds, clubs, hearts, or spades, depending on whatever the value of the suit is that gets passed in. So that's a pretty complicated card class, but it does work very nicely using just integer constants for the suits and the ranks, and these two integer fields for rank and suit. Then when we actually want to create a deck of these cards, we have two values here representing the number of suits, the number of ranks, 4 and 13 respectively. And to get the total number of cards in the deck, we've got to just multiply 4 by 13 in this case. This sets up a double subscripted array of cards. Each row will represent a single suit, and each column will represent a rank. So this will be a 4 row by 13 column double subscripted array. Then we go through this nested for loop scheme here. The outside loop just goes one iteration for every suit from diamonds to spades, and then for each iteration of the outside loop, in other words for each suit, then we go through one complete iteration for each rank and assign an appropriate suit and rank to the specific card in the deck. Then down here we've got this get card method that simply returns a specific card from this double subscripted array based on the suit and rank that we send it. Notice that it's suit -1 and rank -1. That's because over here our values for diamonds, clubs, hearts, spades, or the suits was 1 through 4, and for the ranks was 1 through 13. However, when we set up this double subscripted array right here, the indice values will actually be 0 through 3 and 0 through 12. Consequently, if we pass a suit 1 through 4 or a rank 1 through 13, we have to subtract 1 to get the appropriate location in the double subscripted array, the appropriate row and the appropriate column here. So that's how we set up the deck. Then over here, when we want to display the deck, we'll create a new deck right here. And then we'll go through another for loop inside another for loop, and similarly for every suit, diamonds through spades, for every rank in that particular suit, we'll create a new card, send it the value of suit and rank, and then output the corresponding string value of the rank and the suit as we display every card in the deck. So when we display it, or rather when we run it, and we're running it here in the console so you can see how it works a little bit easier, we've got our entire deck of cards output output, ace of diamonds, the deuce of diamonds, all the way down through king of diamonds, and then the same for clubs, hearts, and spades. There you go. Now, what we wanted you to do then was to take this integer-based card class and deck class and use enumerations to greatly simplify this process. So let's take a look at exactly how we'd want to do that. Here's the corresponding card class. Actually, what we've got here in this file is an enumeration called suit with diamonds, clubs, hearts, and spades as constants. And each constant has a corresponding label that is simply a string identifying diamonds, clubs, hearts, and spades appropriately for each constant here. Here, this represents the actual label field. So each one of these suit constants has an appropriate label. And we've got a constructor here that simply takes the, I should turn off my email. The constructor simply takes a label and assigns it to the corresponding label field for each constant. So when we create an enumeration of type suit, what happens is all of these constants get created automatically, and this constructor then assigns the appropriate label to the appropriate constant. Then we've got a simple function or method right here that simply returns a label. Whatever the label is for the appropriate constant, that gets returned when we call this method. So that's our suit enumeration. Then down here we've got something very, very similar for rank. The difference is, of course, we've got 13 different constants, all representing the appropriate ranks with the respective labels. The value, or rather the field, the string field label here. A constructor here to construct each rank with the appropriate label, each rank constant with the appropriate label, and the same kind of label method here that returns a label. Then, once we get these enumerations set up for the suit and for the rank, then look how easy it is to create a card class. This is it. We simply create two fields, one for rank, one for suit. So this rank field is of type rank, this enumeration. The suit field is of type suit, this enumeration. The constructor simply takes a value from the enumeration, the suit enumeration, a value from the rank enumeration, and assigns those values to the appropriate rank and suit field. Then we've got a simple toString method here that simply calls the rank label and the suit label, so that we return the rank and the label for a particular card, format that right here, and return that as the value from the toString method. Very easy. So that's the card class. Much simpler when we create this enum for suit and enum for rank. Now let's look at how we'd actually create a deck of cards. This is quite a bit simpler also. Instead of using a double subscripted array, we're going to use an array list, and every item in the array list is simply a card. So our deck will be a new array list, and we've got to dimension this array list for the proper number of cards, so we simply take the suit.values.length, this property. Remember in the video it was pointed out that every enumeration has an automatic, or rather a static, method called values that simply returns an array of constants appropriate to the particular enumeration. So suit.values returns an array, and that array contains these constant values right here. And the length property simply tells us how many values are in that array. We do the same thing here for the values, the rank.values array, the dot length property here. So we've got 4 times 13, or in other words 52 cards that we want to store in this array list. Then the constructor for our deck class uses two for each loops, or enhanced for loops, for every suit 1 through 4, for every rank 1 through 13. We want to add a new card to the deck simply by calling the constructor and passing the appropriate enumeration value for suit and rank. So much easier to create this deck. Then to display this entire deck, we use another enhanced for loop. Card is the kind of object that's stored in the array list. Deck represents a single element in that array list, and as we iterate through the array list with this for loop, we simply output the value of the card. This is where the toString method gets printed or called, and the toString method down here simply formats this string with the rank label going right here, the the suit label going right there so that that card value is output. Then when we want to display the deck, we simply create a brand new deck of cards, and with the reference to this new deck, invoke the display function or the display method that outputs the entire deck of cards. So here we go. That's what this looks like. And there we have it. Our entire deck of cards is displayed, ace of diamonds, deuce of diamonds, all the way down till we get to the king of spades. So there you go. Using enumerations to solve this card deck problem much more simply, or much simpler, much easier than using the integer constants. So once again, give you an opportunity to redo this assignment if you've done it already, or to do it if you haven't done it. Do exactly what I've shown you here. In fact, you can just make your program just a mirror copy of what we've shown you here, using the enumerations to create a card, and then a very simple way to create a deck, and then an even simpler way to display that entire deck. So redo this problem if you've done it already. If you haven't done it, go ahead and do this problem, and turn this project in by midnight this coming Thursday, December 11th, and we'll give you credit for this assignment. Good luck on the rest of your finals, and happy holidays. Take care.